This lesson is about solving quadratic equations with the quadratic formula, everyone's favorite. Let's review the definition. Given any quadratic equation ax squared plus bx plus c, the solutions for x are given by the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that the plus or minus symbol in front of the radical symbol is responsible for two different solutions. The first solution for x is negative b plus the square root of b squared minus 4ac all over 2a. And the second solution is negative b minus the square root of b squared minus 4ac all over 2a. These are the two different answers for x that you can plug in to the original equation for x, and it will in fact equal 0. The quadratic formula will tell you the solutions for x without the need to factor or complete the square. Many mathematicians enjoy the quadratic formula because you use simple substitution to plug in the numbers a, b, and c, rather than using algebra. However, you need to be very careful with the substitution of negative numbers. For example, solve 1x squared plus 5x plus 4 equals 0 with the quadratic formula. First, always note the values of a, b, and c. Actually write them down. A equals 1, b equals 5, and c equals 4. This is always how I start the quadratic formula. Second, replace a, b, and c with open parentheses to create a space to substitute your values. So after writing down the quadratic formula, I replace each letter with a parenthesis, and I say negative parenthesis plus or minus the square root of parenthesis squared minus 4 parenthesis parenthesis all over 2 parenthesis. And then I just drop in all my values. Here's where I put in the b, I put in a, I put in c, and I also put in a in the bottom. There was a 1 in parentheses there. Finally, you start simplifying this large expression. I always square my b squared and multiply my 4ac first, and then I subtract my b squared minus 4ac to give me the 9, and then I simplify my root if I can. Now, you want to solve both possible solutions. I normally do this with arrows. I write down negative 5 plus 3 over 2, and then I write down negative 5 minus 3 over 2. And I solve both of them individually, just like I do here. Now I have my two solutions, negative 1 and negative 4. Therefore, given the equation 1x squared plus 5x plus 4 equals 0, if I plug in negative 1, it will indeed equal 0. Or if I plug in negative 4, it will indeed equal 0. You'll want to actually plug in the numbers to check to make sure that it does. That's how you know you have the correct solution. Here's another example. Again, always note the values of a, b, and c explicitly by writing them down. A is 2, b is negative 4, c is negative 70. You want to write them down to make sure you get the negative symbols correct. Second, replace a, b, and c with open parentheses to create a space to substitute all of your values. I have written it down with just my values substituted. I haven't done any computations yet. Next, I square my b term, I multiply 4 times a times c, and I deal with any double negatives if I have them. Next, I add the two numbers in the radical together, and then simplify the radical if possible. And again, I use two arrows to show my two different solutions. Here they are. 4 plus the 24 over 4, and 4 minus 24 over 4. Giving me two different answers, 7 and negative 5. And if you plug either of those numbers into this equation, it will indeed equal 0. And that's how you know you have the correct solution. Here are two practice problems. The first thing you should do is explicitly write down that a is 3, b is negative 6, and c is negative 45. The most common mistake I see is not taking those negative symbols with the b and the c. Likewise here, a is 4, b is negative 4, and c is negative 48. Now you'll plug those numbers into the quadratic formula and get your two solutions for x. Here's the answer key for the first problem. After you solve it, come back and take a look. And here's the answer key for the second problem. After you answer it on your own piece of paper, come back and take a look.